Hello, friends. Welcome to this series on time, speed, and distance. In this seventh session, we look into the concepts and problems based on escalators. So, in the previous session, we had seen uh, the application of boats and rivers under time, speed, distance. So, from there on, we'll continue the similar concept. So, escalators, the problems based on escalators are essentially same as that of the problems based on boats and streams. So when I say it's essentially same as the problems based on boats and stream, it means that let us first see how does the skeleton look like. So everyone would have seen a skeleton in malls and airports, metro stations, railway stations, and I mean many places. So now see, typically what happens? This is the visible part of the escalator, and then there would be a invisible part which we may not be looking at, right? So the red part is the visible one, and this dashed green part is the invisible part which goes underneath or behind the scene which we cannot see. So now what happens typically? So typically, I mean, this escalator would be moving upward. It would be moving upward. I mean, here we take a case of a ascending escalator, that is moving upward escalator. So this escalator is moving, say, at a speed of VE. VE steps per second. So there's one similarity which, I mean, normally in time, speed, and distance, we say that the distance or the speed is in, say, meter per second. But in case of escalators, the normal unit used is steps. Step is a unit of distance. So in case of escalator, step is a unit of distance. So therefore, step per second becomes the unit of speed. So VE steps per second is the velocity or the speed of the escalator, right? And now suppose a man is standing here on this escalator, and a man is also walking upwards with a speed of vm step per second. So what would be the effective speed? Effective speed of the man up in the upward direction would be nothing but the combination of the two speeds, vm plus ve. How is it? I mean, this we had seen in the discussion on uh, boats and rivers. Herein, when we see say vm step per second is the speed of man on escalator. This means that this is a relative speed. I mean, this man is moving at a speed of vm step per second in respect to the escalator, right? Not with respect to the ground. So that is what we had seen in boats also. So effectively, I mean, if we see an example, suppose here is a bus, right? And a person is standing here. A person is standing here. Now this is the ground. Just to give a flavor, I mean, how does this work out? Because many people confuse this with a relative speed, that when the two objects are moving in same direction, should it not be a negative? But actually it will not be, because the frame of the reference is different in two cases. So here, when we say this bus is moving in this direction, right? So at this junction, this tire of the bus is at this a part. Now after some time, what happens? The bus reaches, say, this location. So we'll see the same tire here, it moves at this location which is a dash, right? Now while, and say this happens in time t, right? So but in during time t, what happens? A man also moves in this bus from, say, this tire, it reaches the front wheel here. So during time t, the man reaches here, man reaches here. So now, what is the effective distance? What is the effective distance covered by the man during this time? So is it not this distance a dash plus, so the total distance covered by man would be what? Man position change. I mean, initially man was with respect to ground, man was at a position A, and now finally man is at a position B dash. So the total distance covered is A to B dash, right? A to B dash, out of which A to A dash has been covered by bus plus A dash, and this distance has been covered by man, right? Because man is also walking in that t second. So it means that A dash to B dash, this distance is covered by man. So basically, now A to A dash, what is this? A to A dash is a distance covered by the bus, right, in t second. Let us assume that t is 1 second. So it becomes the speed A to A dash. We can say that this is nothing but the speed of bus, right? Distance covered in 1 second plus distance covered by bus, and this A dash to B dash is nothing but, I mean, man from this rear wheel reaches this front wheel. So here the man, this is the distance covered by the man, right? So in respect of speed we can say this is the velocity of man. So now see, effective distance was A to B dash, and when we say A to B dash here, and this distance have been covered in t second, which is 1 second, so this becomes the speed also. So the effective speed is nothing but v is equal to vb plus vm, and this is how we have written here, right? So the frame of reference is important here, right? Those of you who did not get this may refer to our discussion on relative motion and discussion on reverse and streams. So therein, and boats, therein we have contrasted these two concepts of relative motion and the motion on a boat or motion on a escalator, right? So here therefore we can say that the relative, here we can say that the effective speed of man is nothing but the speed of man plus the speed of escalator, right? So this is the important relation. Now a second case 2 we will see. Case 2 is that the same escalator, now escalator is going down, that is a descending escalator at a speed of ve, whereas man here is going up at a speed of vm, right? So effectively man would be going, reaching this top of the escalator. So what is the effective speed here? Effective speed, say in the case of downward uh, or descending escalator, would be nothing but vm minus ve, right? What will happen? I mean, man would try to go up. So in say 1 second, man will go up by vm step, whereas the escalator will pull him down by ve step. So therefore, in 1 second, this is the effective distance vm minus ve, and that becomes the distance. So vm minus ve steps per second. So therefore, effective speed becomes vd is equal to vm minus ve, right? So this also we can say. So the same thing here I have written, that the effective speed of a person is dependent on whether the person is climbing up on a stationary escalator. Speed of the person is given by the vm. That is, if the escalator is not moving, then this v value is 0. So in either case, we will get effective speed as nothing but vm, right? Because ve is 0. Whereas in the upward, when a man is climbing up a downward moving escalator, the effective speed of a person is given by vu is equal to vm minus ve. And when the man is climbing up an upward moving escalator, the effective speed of a person is given by vu is equal to vm plus ve. So these three relations, I mean, we should keep in the back of our mind, because and very simple, also quite intuitive, nothing to remember. But the concept was important, which I discussed some time back. Now, after having covered this concept of effective speed, one more thing which we should uh, now see what happens. See, this is the ground floor, and here the escalator starts, right? And up till here it goes, and here it reaches the first floor. So effectively, what happened? This is the portion of escalator which we can see, and then the remaining portion which we cannot see. That is a, so the number of steps in escalator, and we know that the number of step is nothing but total distance, right? In terms of escalator, the number of step represents the distance. So the, and this number of steps in escalator, which is visible to us, that is essentially the distance between the ground floor and top floor. Distance between ground floor and first floor, right? This we can say. So suppose this is ground floor and this is first floor. So the number of steps visible on escalator is nothing but essentially the distance between the ground floor and first floor, and that is constant because that distance is not going to change. So therefore, from here we can say that the number of steps in an escalator is always constant, and that is equal to the number of steps covered by the person plus the number of steps covered by escalator, right? This we have seen also. I mean, here this relation here represents the same thing. The total distance covered is equal to the distance covered by the bus plus the distance covered by the man. Now replace bus by escalator and man remains the man here. So right, so this relation actually shows that the total distance covered is equal to the total distance covered by the person plus total distance covered by the escalator. And here distance is represented by steps. So I mean that is a unit of distance in case of escalators. So this is the case when the both are moving in same direction. If the escalator and man are moving in opposite direction, then there would be one negative sign for the obvious reason which we have seen. So with this in the background, this much of a basic in background, now we move to solving questions, and through that we even consolidate our concepts even further. So let us see question number 1, which reads that Samir takes 30 seconds to reach first floor of a mall, climbing up a stationary escalator, but 18 seconds when the escalator is moving up. If the speed of the escalator is 4 steps per second, how many steps are there in the escalator? Now see, a very basic problem. It says that Samir takes 30 seconds to reach the first floor, right? So what is the effective speed with which Samir would be moving? The effective speed upward would be what? Velocity of escalator plus velocity of man, here Samir, V plus Vm. Both are moving in the same direction. Escalator is moving up and uh, Samir is also going up. So this is the effective speed. And so what would be the number of steps in escalator? That is the total distance to be covered, and that is equal to speed into time. So Vu into time, right? This we can say. So n, if this is given n is equal to Vu. Vu is nothing but Ve plus Vm into t. Time taken is 30 second. 30 second. First case. And in the second case, 18 second when the escalator is moving up. So now see, in the first case, here V is 0, right? This is stationary escalator. So from here we can say that n is equal to 30 Vm. Case 1. Case 2, when escalator is moving up, it's 18 second. So n would be what? Ve plus Vm into 18 second, right? And here Ve is given as 4 step per second. So this I can further write as 18 into Vm plus 4, right? And these two should be equal. So from here I can say that, I mean, both are equal to n. So I can say that 30 Vm is equal to 18 Vm plus 72. From here I can say 12 Vm is equal to 72. So that gives velocity of Samir is nothing but 72 by 12, which is 6 steps per second, right? 6 step per second. So this is fairly simple. Here what we did, we had been given two cases, two different scenarios. Two scenarios, we know the number of steps visible would be constant, right? Why are we equating? Because case 1 and case 2, the number of steps on the escalator would remain constant. Why? That we have seen. The number of steps visible on escalator is nothing but that represents the distance between the ground floor and the first floor, and which remains constant. So therefore n is constant. So if n is constant, we equate the two equations, and then thereby we get the value of the speed of Samir, right? This is the answer to this question. Moving to the next question, example 2 says a man can walk up in an ascending escalator in 30 seconds. The same man can walk down the same ascending escalator in 90 seconds. Assume that his walking speed is same when going up or coming down. How much time will it take to walk up the escalator when it's not moving? Right. So now see, there's two way of solving this. First case, method one we'll discuss first. The conventional method of a man walks up in an ascending escalator in 30 seconds. So this means that the number of steps in escalator, that is distance, would be speed into time. Speed is, effective speed is what? Vm plus Ve into 30. And the same man can walk down the same ascending escalator, that is distance covered is again same n, and that in opposite direction, that is Vm minus Ve, the effective speed, in 90 seconds, right? So we will equate the two equations. So hereby it's given that when we equate this becomes Vm plus Ve is equal to 3 times 30 into 390. So 3 Vm minus 3 Ve. So from here we can say that Vm is equal to 2 Ve, right? So this we will substitute there. So this is the relation which we obtained. Now we can say that we have been asked how much time will he take to walk up the escalator when it's not moving. So now again the number of step, the distance to be covered remains same n, and that is when the escalator is not working, is stationary. So in that case, man will have to do all the work. So that is Vm into t second. Let's suppose he is taking walking on a stationary escalator, and that should be equal to nothing but the say first equation, equation 1, which is Vm plus Ve into 30. From here we can say that Vm into t equal to Ve is nothing but Vm by 2. So it becomes 3 Vm by 2 into 30. So therefore Vm gets cancelled out. So from here we can say t is nothing but 45 second. This is the answer to this question. I mean, conventionally we uh, dealt with all the three scenarios. Scenario 1, when the escalator is moving and they are going in same direction. Scenario 2, when escalator is moving but the two man and the escalator are going in opposite direction. And then scenario 3, when escalator is not moving and then man is walking on the escalator at a speed of Vm steps per second. So with these three equations we solved and got the answer. However, there's a very standard and easier approach to solving this problem. What is it? Let us see. And this we have seen in boats and rivers also. Here in see what is the speed in three scenario. Scenario one, when both are moving, so effective speed is Vm plus Ve, right? When both are moving in same direction. When the two are moving in opposite direction, the effective speed is Vm minus Ve. And when one is stationary, the effective speed is Vm only. So now see what is this? This is in AP series. So we can say that speed speeds are in AP. So therefore, we know that when speeds are in AP, that implies that the time and with this, and the distance covered in all the three scenarios are same. This scenario, and this scenario. The distance covered in the three scenarios are same. So when the distance covered in the three scenarios are same, and the speeds are in AP, so the time taken would be in time taken would be in HP. That is harmonic progression. So therefore, the time taken when it's stationary, that time t will be nothing but 2 into time taken in the first case into second case into say third case upon t1 plus t3. And here the time taken in the first case is when v1 plus vm plus ve takes 30 second. This takes 90 second. So this is t. So this becomes 2 into 30 into 90 upon 30 plus 90. So here it becomes 2 into 30 into 90 upon 120. Effectively we get 45. So this is much easier and a very smart way of solving this question. Whenever we have been given time and we know that they are covering the same distance and the speeds are in AP, we can very much say that the time would be in HP, right? Harmonic progression. So time is nothing but the harmonic mean of the two given times, and that becomes 45 seconds. This is method 2. Method 2. Now let's move to question number 3. It's also similar. Starting from top, Anil takes 30 steps to reach the bottom of a descending escalator. Amar takes 70 steps to reach the top of the same escalator starting from the bottom. The speed of Anil and Amar are equal. Find the number of steps in escalator. So let us see how does this, what does this question mean? This is a escalator. So Anil starts from top, and escalator is a descending escalator, that is it's moving downward at a v step per second. Anil also starts moving downward, right? Amar starts from the bottom and goes up, right? So this is the scenario. Let us assume that the speed of Anil on escalator is say vx and Amar be vy, right? So we'll take the scenario of Anil first. In that case, total number of escalator, that is n, number of steps on escalator n, will be nothing but what? Effective speed here will be ve plus vx into time taken is, time taken we do not know, right? Time taken we do not know, that let that be t. But here we know that Anil takes 30 steps. 30 steps walking at a speed of vx, he takes 30 steps. So can we say time is equal to nothing but distance, that is 30 steps upon Vx. So this we can write. So here we will write Ve plus Vx into 30 by Vx. Right? 30 by why time is nothing but distance upon speed. Anil covers 30 step distance at a speed of Vx. So therefore time becomes 30 upon Vx. This is n. Now for the case of Amar, total steps on the escalator remains same, right? That is n, and that is again ve minus, sorry, here it will be vy minus ve, and at a certain time t2, and t2 T2 will be nothing but distance covered by Amar, which is 70 steps, upon speed of Amar, which is Vy. So here we can write Vy minus Ve into 70 upon Vy. Now we'll equate the two cases because the number of steps on the escalator which is visible remains constant. So therefore we can say that Ve plus Vx into 30 upon Vx is equal to Vy minus Ve into 70 upon Vy. Now it has been given that the speed of Anil and Amar are equal. So this means that essentially Vx is equal to Vy. Here I have assumed a different speed to generalize the case. However, finally it has been given that speed of the two are same. So Vx is equal to Vy. Let that be equal to simple V. Right. So we can say that it's V and this cancels out. Vx Vy is same. So this also cancels out. So what remains is 3Ve plus 3V is equal to 7V minus 7Ve. So from here we can say that here we can say that 10VE is equal to 4V. 4V is equal to 10VE. So we have been asked to find the number of steps. Number of steps. So number of step in any equation we can take, that is VE plus V into 30 by V. This is the number of step, right? So here if we take V, this becomes 1 plus VE by V into 30, and VE by V is nothing but 4 by 10. So it becomes 14 by 10 into 30, which gives 42 steps, and this is the answer to this question. So nothing serious or difficult we did. What we simply did, we had been given two scenarios, wherein in first scenario Amir is walking down a descending escalator, and in the second scenario Amar is moving up a descending escalator, and we know that the number of steps on escalator remains same. With the number of steps on escalator, that is V plus Vx into my effective speed into time taken, and y- then we equated the two and we obtained a relation between the speed of the persons and the speed of escalator, and using that we substituted that in the any of the equation and we got the value of n, which is the number of steps on a escalator. So that is the process which we essentially adopted. Now next problem, question number 4 reads that Akshay walks down an ascending escalator and takes 150 steps. Abhishek walks up the same escalator and takes 75 steps. If Akshay takes 3 times as many steps in a given time as Abhishek, find the number of steps visible on the escalator when it is stationary. So it's really same problem, same problem. So what happens here? Akshay walks down an ascending escalator and takes 150 steps, right? So now directly I will write, if Akshay takes times as many steps in a given time as Abhishek, so can we not say that speed of Akshay, I mean here, so speed of Akshay, if it is 3 times the speed of Abhishek, so if Abhishek is V, Akshay will be 3V. So for the case of Akshay, we can say 3V plus velocity of, I mean speed of escalator, that is the effective speed. No, Akshay is walking down an ascending escalator. So this becomes 3V minus VE into time. Time we do not know, but we know that Akshay has taken 150 steps. 150 step at a speed of 3V gives a time taken. And this will be equal to the case for Abhishek. Abhishek walks up the same ascending escalator. So effective speed will be V plus E, and he takes 75 steps. So Abhishek covers 75 steps at a speed of V. So time will be 75 by V. When equate the two here, V gets cancelled out. 3 cancels 150 50 times, 50 will cancel 25 2 times, and here 3 times. So now we'll simplify this. 6v minus 2ve is equal to 3v plus 3ve. So from here we can say that 3v is equal to 5ve, that is ve upon v is equal to 3 by 5. So we have been asked the number of steps visible. Number of steps visible. So what would be the number of steps visible? Right. So n, we will take any of the equation. N will be 3v minus v into 150 by 3v. Right. Here ve we will substitute at as 3 by 5v. So this means 3v minus 3v by 5. Right. We're substituting from this equation into 50 by v. 150 by 3 is 50 by v. So basically this becomes what? This is nothing but 15 12 by 5 v upon v into 50. So 10 times v cancels out, it becomes 120 steps. So pretty easy question. We first found out the ratio between the speed of person and speed of escalator, and then we substitute the same in any one of the case. Here we have to find the number of steps, and number of step is equal to 3v minus v into, that is effective speed into time. So that using that we obtain the answer as 120 steps. Question 5 reads, Atul takes 90 steps to reach the top of an escalator which is moving upwards. That is, Atul and escalator are moving in the same direction. Now, Bhairav, who is faster, takes 100 steps to reach the top of the escalator. If Atul takes 4 steps for every 5 steps of Bhairav, find the number of steps visible when the escalator is stationary. So, first of all, let us discuss about the speed of Atul and Bhairav. It is given that Atul and Bhairav, Atul takes 4 steps in the same time in which Bhairav takes 5 steps. That means Atul covers 4 unit of distance in the same time when Bhairav covers 5 unit. So the speed will be in the ratio 4 is to 5. So let us assume that the speed is 4x and 5x. Right. So now this is the speed of Atul and Bhairav. Now Atul takes 90 steps to reach the top. What is the effective speed of Atul? Same direction, so it will be 4x plus velocity of escalator into time. Time is what? 90 steps Atul has covered at a speed of 4x. So 90 upon 4x. Right. This is equal to case of Bhairav, wherein Bhairav is moving. Bhairav is also going in the same direction. Right. He is also going, reaching the top of a ascending accelerator. So it becomes 5x plus VE. Meanwhile, he covers 100 steps. 100 steps at a speed of 5x. So time is 100 upon 5x. So now x will get cancelled out in the denominator. Right. So here it is 22.5 and here it is 20. Here it is 20. So now let us see what does this. Let's solve. This becomes 90x plus 22.5 VE is equal to 100x plus 20 VE. Right. So therefore this becomes 2.5 VE is equal to 10x. So we can say that VE upon x is equal to 10 upon 2.5, which is nothing but 4 by 1. So this ratio we have obtained, VE upon x. Now we have to find the number of steps in the escalator. We take, that is n. N we can take any one. So let us take n is equal to 5x plus ve into 20 upon x, right? 100 by 5x is 20 upon x. And v by x will take inside. So this becomes 5 plus v by x is nothing but 4, right? Into 20. So this becomes 9 into 20 is 180. 180 steps is the answer. So pretty easy, nothing much to do. I mean, on the similar line, what we have been doing so far. Now let's move to question number 6. Gradually, we'll increase slightly the difficulty level. I mean, questions cannot be very difficult on escalators and boards and streams if the concepts and the understanding is clear, right? So let us move to question number 6 here. Atul takes 60 steps to reach the top of an escalator, and Samir, who is faster, takes 48 steps to reach the top of the same escalator. If Atul takes 3 steps for every 4 steps of Samir, find the number of steps in the escalator and find out whether it's an ascending or descending escalator. So here it's not given whether it's an ascending or a descending escalator. So here what we will do, I mean, the best way is we'll assume any case. Suppose it's a descending escalator or ascending, any one case we will assume and then we'll check, right? So first of all, let us sort out the speeds of Atul and Samir. Atul and Samir. Atul takes 3 steps for every 4 step of Samir. So ratio is 3 is to 4. So 3x and 4x, let the speed be 3x and 4x for Atul and Samir. Now let's assume that escalator is descending. Let us, I mean, we can assume anything. Uh, in one of the case, we'll get a positive answer, I mean, valid answer. Other case, we'll not throw up a valid answer to the question. So that is the only way to sort this out. Now, if we have assumed that the escalator is descending, so what happens? I mean, so in that case, Atul and escalator are moving in opposite direction. So the number of steps on escalator n is nothing but what? Velocity of Atul, which is 3x, minus velocity of escalator into time taken. Time taken by Atul is what? 60 steps upon 3x, right? And this will be same as for the case of Samir, wherein Samir is moving, is also going to the top, right? So opposite direction. So 4x minus VE into 48 upon 4x. So we'll solve these two equations. So what will it be? Let us see. X will get cancelled out. This will be 20 and this will be 12. Again 4 3 ja and 4 5 ja. So let us see. It becomes 15x minus 5 VE is equal to 12x minus 3 VE. From here we can say that it's 3x is equal to 8 VE. Sorry, 2 VE. Right, 3x is equal to 2 VE. So VE upon x is equal to 3 by 2. This ratio we have obtained. So we have to find the number of steps. Number of step n is equal to any, we can take any equation, 3x minus VE into 60 by 3x, which is nothing but 20 by x, and we'll take x inside, so it becomes 3 minus VE by x is 3 by 2 into 20. So 3 minus 3 by 2 is 1 by 2, right? 3 minus 3 by 2 is 3 by 2. 3 by 2 into 20 is 30. So this is 30 steps is the answer to this question. And whether it's moving ascending or descending, it's ascending. Now I just, for the sake of here, I do here for ascending also, but in that case we'll not get a valid answer. So case if escalator is ascending. So in that case, it will be n is equal to 3x plus VE into what? 60 upon 3x, which is 20 by x, and that is equal to 4x plus VE into 48 upon 4x, which is what? Which is 12 by x. Right? We can say this. Now, see here, if we solve this, we will get 4 3 ja, 4 5 ja, 15x plus 5VE is equal to 12x plus 3VE. Now see this, here we will get a relation which is negative, right? So from here we will get 3x is equal to minus 2VE. So it means that if x is moving in one direction, v will be opposite. So this also gives, refers to the same thing, right? This also, I mean, if we assume ascending, it will refer to a case where say that, I mean, this is not a ascending, but rather it will be a descending. So in that case, x by ve will be x by ve, or rather ve by x will be 3 by 2 with a negative sign, right? So now when we substitute this in this equation, we'll get the answer. Here also we'll get the answer. Here also if we substitute this in any of the equation, so it becomes what? 3x plus VE into 12 into 20 by x, right? So it becomes 3 minus 3 by 2 into 20, which is 30 steps. So this will also give an answer to this question. However, from here, since we get a negative relation, meaning that the two are moving in opposite direction, so therefore this will also help us answer whether it's ascending or descending. So now, since both are in opposite direction and Atun is going up, right? Atun and Samir both are going up. So therefore, to maintain or to honor this negative sign, escalator will have to come down. So any method we can take and we can reach to the answer, right? So question number 7 now say that Atun takes 180 steps to reach top of an escalator which is moving upwards in 30 seconds. Bhairav, who is faster, starts simultaneously from the top, takes 40 seconds to come down using the same ascending escalator. If Atun takes 3 steps for every 4 steps of Bhairav, find the number of steps from bottom after which they cross each other. So this is a relatively good question. Let us see what does this mean. So and try to pictorially represent this. So Atul takes 180 steps to reach the top of an escalator. So Atul starts from here, going up, right? Which is upward moving. Escalator is upward moving at a speed of VE. Bhairav, who is faster, starts simultaneously from the top. So Bhairav is here, sitting here. He will start going down. And now, speed of Bhairav and uh, Atul. So it says that uh, Atul and Bhairav speed would be 3 is to 4. Right. Let us assume that it's 3V for Atul and then it will be 4V for Bhairav to honor the ratio of 3 is to 4. So this is the data which has been given to us. Now, as we do, we will, number of steps on the escalator is constant for both of them in either case. So that we will equate. So that will be nothing but n is equal to what? Effective speed is, effective speed for Atul would be what? Moving in same direction. So 3V plus VE into time is 180 steps at a speed of 3V, and that will be same as, that will be same as for Bhairav it's 4V minus VE into, Bhairav takes 40 seconds to come down, whereas 30 second, Atul takes 30 second, and so therefore can we say this value is 30 second, that is 180 upon 3v is equal to 30 second. So from here we can say 3v is equal to 6, right? So v is equal to 2 steps per second. So what will be the speed of Bhairav? It will be Vb will be 4v, that is 8 steps per second, right? How 8? 2 into 4, 4v. So 2 into 4. So here we can say, now we'll substitute the same. I mean, let us now solve this. So what happens here? What happens here? That 3v will be what? 6 plus ve into 30 will be equal to 4v is 8. 8 minus ve into 40. Much simplified form we have obtained. So this 0 0 cancels out. Here it becomes 3ve plus 18 is equal to 32 minus 4ve. So therefore v 7v is equal to 14. So v is equal to 2 steps per second. So ve and uh, all the speeds we have obtained. So what is the effective speed of Atul is what? 3v plus ve, that is 6 plus 2, which is 8 steps per second. And effective speed of Bhairav would be what? Opposite direction. So it will be 4v, that is 8 minus 2, which is 6 steps per second. Right? 6 steps per second. So therefore ratio is what? 4 is to 3. So now see, a total distance of n has to be covered. The total steps, n step has to be covered, and both are traveling with a effective speed of 8 and 6 steps per second in opposite direction. So here we apply relative motion. So time to meet is what? Time to meet is, and we can find n also here. What is the value of n? That we'll substitute ve here. So n will be what? 3ve, 3v6 plus v8, 8 into 30, which is 240, 240 steps, right? This also we have obtained. So now, I mean, we did not even find out time directly and right, because we know the concepts of relative motion. So nothing much to drag upon. So here it will be from bottom. I mean, when they meet, so the meeting point from bottom will be what? From bottom Atul is going, so the effect, it will be 8 upon 14 into total distance is 240, right? So this becomes 2 4 ja 2 7 ja. So this is after which step they cross each other. So let us find this value. So this becomes what? 7 3 ja 1 3. So rather it becomes 8 upon 14 into 240, which is 2 4 ja 2 7 ja. So this is nothing but 960 upon 7, which is 1 7 1 ja 2 7 3 ja 21 4, then 7 5 ja 35, then 7 something. So after which step they will meet from bottom? So after 135th step. So after 135th step from bottom, they will meet. They meet after 135th step from bottom. This is the answer to this question. Right? Nothing. I mean, we obtained the speed of everyone, the Skeletor, the Atun, and Bhaira, and then since they had to cover this distance in opposite direction, so at what distance? So using relative speed, we could find that it's 135 fifth step from the bottom. Now let's move to question number 8, a fairly simple one only. Abhay has to reach the next floor in a mall. If Abhay runs up 10 steps of the escalator, then it takes him 40 seconds to reach the next floor. If he runs up 15 steps of the escalator, it takes him only 35 seconds to reach the top. How many seconds would it take Abhay to reach the top if he did not run any steps of the escalator at all? Right. Now see here. Now just first let me draw the. This is escalator. Abhay has to reach the next floor in a mall. If Abhay runs up 10 steps of a escalator, it means that Abhay runs only up to 10 steps and then stands still and let the escalator carry him up to the first floor. Whereas, and the whole process, it takes 40 seconds. Whereas, if he runs up to 15 steps of the escalator, then it takes him only 35 seconds to reach the top. So how does it work out? So total number of step, the total distance remains constant. Of this total distance, in the first case, Abhay has run 10. So the remaining will be covered by what? In the meanwhile, in the same time, that is 40 seconds, escalator would also be moving at a speed of VE. And in the second case, where Abhay has run 15 steps, and in 35 seconds escalator would also be covering certain distance, combined two, it will be, both will be equal to n. So here we can say that 10 plus 40 VE is equal to 15 plus 35 VE. So this means that 5 VE is equal to 5, that is VE is equal to 1 step per second. Speed of escalator is 1 step per second. That is what we have obtained here. So we have to find how many seconds would it take Abhay to reach the top if he did not run any step. That is, Abhay is not moving. So in that case, in we total that remains constant. Here to be VE into time t, and that n we can equate to any one of this. So that is nothing but 15 plus 35 into 1. So from here we can say that t is equal to 50 second, right? So this is the answer to this question. Now, just to ponder upon, can we use this relation that why no? But anyway, both are moving in same direction. So this APGP thing anyway not applicable. Had this two movement been in opposite direction, then also, I mean, say suppose in the first case it is 10 plus 40 VE. In the second case it is 15 minus 35 V. Assuming that in in the first case, that is Abhay goes up, when going up takes 10 steps and remaining by the escalator, and when coming down runs 15 steps and the remaining by escalator. But can we use the uh, harmonic mean concept here? Thing is no. Why is it? Because see, uh, it's not harmonic mean can only be applied if the distances covered in all the three cases are same. But here, see, Abhay has not run on the, or I mean, from a start to the end. I mean, he started running and then stopped midway in the first case. Similarly, in the second case, he started running, he stopped midway. So therefore, that case that we could not have used. However, in this given question, when both are in both the cases they are moving in the same direction. So anyway, that question did not arise, right? So we'll move to the next question. Now question number 9. Mayank walks upward on an escalator with a speed of 2 steps per second. After 40 steps, he reaches the next floor. Right. Then he turns around and run downwards with a speed of 3 steps per second. After 90 steps, he is back at the beginning of the escalator. Right. How many steps does he need to climb if the escalator is stationary? So now see, here in the first case, that is time taken by Mayank to go up is what? At a speed of 2 steps per second, 40 steps. Right, the 40 upon 2, which is 20 second he takes. And the time taken by Mayank to come down at a speed of 3 steps per second, he covered 90 steps. So it becomes 90 upon 3, which is 30 second. Right. So now we can equate total distance, that is n, is equal to, in the first case its effective speed is 2 steps per second plus VE into 20, and that is equal to 3 minus VE into 30. Right. These two equations we will equate. It becomes 4 plus 2 VE is equal to 9 minus 3 VE. So 5 VE is equal to 5. So therefore VE is equal to 1 step per second. Right. So how many steps does he need to climb if the escalator is stationary? Right. So if escalator is not moving, so n remains constant. That is equal to 1 step at a speed of VE. Well, V0, right? V is 0. So let us find the number of steps on escalator, that is VE plus 2 into 20. So this gives 20 into 3, which is 60 steps. So now when the escalator is stationary, it means that Mayank will have to walk up 60 steps to reach the top, right? So 60 steps is the answer to this question. Moving to question number 10, I believe this is the last question for this session. It says that on an ascending escalator, Amar, Akbar, and Anthony takes 30, 24, and 18 steps respectively to reach the top. On the same upward moving escalator, Amar takes 45 steps to come down from top. Find the ratio of time taken by Akbar and Anthony to reach the top. To reach the top. So, good question. We can say it says that on ascending escalator, let us Amar, for Amar it's both way, going up, ascending and descending both the directions. The number of steps taken by him is given, right? So let us, for Amar, let us first solve. Amar, Akbar, and Anthony. Let us assume that the speed is x, y, and z. Their respective speed is x, y, z. So the number of steps covered by, total number of steps on escalator would be what? For the case of Amar, it will be effective speed is x, and Amar is walking up an ascending escalator, so x plus VE into time taken is what? Time taken is 30 upon x. He takes 30 steps at a speed of x. This is same when he comes down. When he comes down at the same speed of x, then it's minus VE, right? Into time is 45 upon x now. 45 upon x. So if we solve this, we can say that 2x plus 2VE is equal to 3x minus 3VE. So it becomes x is equal to 5VE. X is equal to 5VE. right? So this is the ratio which we have obtained, that the speed of Amar is 5 times the speed of escalator. Now we have to find the ratio of Akbar and Anthony. So from here, first let us find the number of steps. N will be what? N will be x plus VE into 30 by x, and x is nothing but 5 VE. So we can say that 6 VE into 30 upon 5 VE. It cancels out. So that is 36 steps, right? 36 steps. So we know that N is equal to 36. Now for Akbar we will see. Akbar effective speed will be what? Y plus VE into, Akbar takes 24 steps, 24 upon Y, right? So from here we can find out 12 will cancel out 24 and 36 two times and three times respectively. So it becomes 1 plus VE by Y is equal to 3 by 2. So therefore we can say that VE by Y is equal to 1 by 2, or Y by VE is equal to 2. Another relation we have obtained, right? Y is equal to 2 VE. And then third case, for Anthony, N remains same as 36. Effective speed for Anthony will be Z plus VE, and time taken will be what? Anthony takes 18 steps. So 18 steps at a speed of Z. So it is again same as 1 plus VE by Z is equal to 2, right? 18 will divide 36 two times. So from here we can say VE by Z is equal to 1. So this means that VE is equal to Z. And here Y is equal to 2 VE. So therefore we can say that the ratio of speed of Akbar and speed of Anthony is nothing but Y by Z, which is 2 is to 1. This is the ratio of speed. We have to find the ratio of time taken by Akbar and Anthony. So time taken by Akbar and Anthony will be what? Now see, time taken will be in the ratio of effective speed, right? Time taken will be in the ratio of effective. Both are covering the same distance, but at a different effective speed. So now this is a ratio of their individual speed. So here in this box I write, so effective speed of Akbar, ratio of effective speed of Akbar and Anthony is what? Akbar is to Anthony, Akbar own speed is 2, right? So with respect to VE, I mean that is Y plus VE, right? So we can say it will be Y plus VE, and Y is 2 VE, so that we can say 3 VE upon, for Anthony it is Z plus VE, and Z and VE are same, so that is 2 VE. So the ratio is 3 is to 2. So the ratio of time will be inverse. So ratio of time will be 2 is to 3, right? So that is the answer. Ratio of time will be 2 is to 3. Because to cover the same distance, the effective speed is 3 V upon 2 V, ratio is 3 is to 2. So the ratio of time will be 2 is to 3. So that is the answer to this question. So this was also, I mean, not very difficult, but slight use of different concepts of ratio, time, speed, and distance, and some basics of escalator, right? So with this, we'll close this session. Any query you can get back to us. Thanks for watching this video.